Welcome everyone to another Khan Academy tutorial. Today we're doing system of equations word problems. There's two different word problems in Khan Academy. One is like an Algebra 1 category, one is an 8th grade category. This one is technically the 8th grade category. I'm going to be honest, it's pretty tough. So you get two different styles approaches with the two different Khan Academies, but both have some difficult problems. Anyway, let's break this down. We have Takaro only uses eggs for souffles. In his restaurant, he uses 3 eggs per souffle. Last week, he bought 4 times as many eggs as he bought souffles. Takaro had 18 eggs left over. How many eggs did Takaro buy and how many souffles did he bake? This one's tough because it breaks up the information per equation in a weird way. Now, the first thing that we're going to do, kind of with that breakdown aside, is we have to define which variables we're looking for and like what we're trying to find in the problem. So we have here that we have Takaro bought blank eggs. So we know that eggs is going to be one of our variables. So we're going to say eggs is one of our variables, and it's talking about the number of eggs. We want to know how many eggs we made or used, bought, whatever. You guys know what I'm talking about. Number of eggs. The second variable that we're looking for is the number of souffles baked. Now, I don't like using S because it looks like a 5, so I'm going to make souffles with an F, and that's number of souffles. Okay, a little tilde. Okay. Now, so we have eggs, we have souffles, and now we need 2 equations because we have 2 variables. Anytime you have 2 variables, we know we're going to be using 2 equations, which means we're going to be solving a system of equations. That's what we're doing here. Right. So now we need to figure out what our 2 equations are. Now, he uses 3 eggs per souffle. All right. That's a piece of information, but this isn't the whole information. We're going to be using this later, but that's not a whole piece of information that we need for an equation, because we need to know, like, if we're baking, how many eggs we bought so we can use those eggs. Now, because it's asking for bought eggs, not used eggs. That's very clear, okay? Used eggs baked. And that's why this one's tough, because I guarantee some people made mistakes in this one that, oops, sorry, not baked. I want bought. Because you might form an equation based on used, but it's bought eggs. That's the variable. Number of eggs bought. I should write that up there. And then number of souffles baked. That's very important. Okay, I was kind of trivializing that earlier, but it's very important. Okay, now that we know that we're looking for bought eggs, we need an equation that uses that. So last week he bought 4 times as many eggs as he baked souffles. Now we can get somewhere. Okay, now we can get somewhere because we can say that the number of eggs, is equal to 4 times the number of souffles. Now, what's the temptation here? The temptation here is to write 4 times the number of eggs equals souffles. Okay? This is something even I do occasionally if I'm doing this quickly. You don't want to do this. This essentially means that the souffles will be 4 times as great as the eggs. You're like, well, I wrote 4 times E, so why is it that way? If you want something to be a bigger number, okay, for variables in relation to each other, this essentially means when you have the E over here on this side and then 4 times F on this side, this means that this is the bigger number and this is the smaller number on the right. And why is it the smaller number? Because you have to multiply it by 4 to equal the bigger number, okay? We buy more eggs than we have souffles. So the E needs to be a bigger number. That means that we have to multiply the number of souffles by 4 to equal the number of eggs. Kind of counterintuitive. The more you do these types of problems, the more you grow accustomed to setting up problems this way. But I'm going to be honest, it is a little weird. Okay. Now, with all that being said, we finally have our first equation. Okay, this was the information we used for our first equation. So we got 1 down. Now we need a second one. Okay. The second one's not as easy to see. We say Takaro had 18 eggs left over. Okay, so we had 18 eggs left over. Now, how do we form this second equation? Well, if he bought, we have to use the first part. He uses 3 eggs per souffle. Okay, so he uses per souffle, he uses 3 eggs. So for this equation, we're going to write, circle this completely. We're going to say per souffle, I'm looking for my yellow or purple. Per souffle, he uses 3. It's not, I'm sure why it's working. There we go. We're using 3 eggs per souffle. So per souffle, we're using 3 eggs. Okay. Now you're like, oh, you just wrote 3F. That's because we're using 3 times the number of eggs per souffle. Okay. Now the eggs that we bought, we'll say that E is the eggs that we bought. Okay, is represented by E. So with the bought eggs, E minus 3 eggs per souffle. Okay. So the total number we bought minus the 3 eggs we used per souffle is going to equal 18 eggs left over. Let me explain what I just did. This first equation was all about the total number of eggs bought. This was the number of eggs bought. Okay, last week. This second equation is only talking about how many we used. Okay, so eggs, my goodness, this pencil. Eggs we used, okay, baking. But we still need to take in consideration the number of eggs we bought. Notice how this number is the same. This E is the same. But we subtracted the number of eggs we used per souffle. Eggs used per souffle. Okay, souffle. Who knows how to spell that? Souffles. And then we have the eggs left over on the right. This is super complicated. Okay, this is a tough problem. Like, thank God this is the first question. Hopefully it gets better after this. But this is the leftover. Okay, now the whole point here is that once we get these 2 equations, we can use a system of equations, either elimination or substitution. I think substitution is the way to go here. So I'm going to rewrite these just because I made a mess. We have E equals 4F, and then we have E minus 3F equals 18. Okay, so what I'm going to do here is I'm going to substitute my value of E into my other equation. So I have 4F minus 3F equals 18. So we do 4F minus 3F, and I get F equals 18. So 4F minus 3F is 1F, F equals 18. Now this is good news because now we know how many souffles we baked. We baked 18 souffles. Okay, so we got that first part done. Now all we have to do is substitute. Once we have a value of F, we can just substitute this value in for F. And so what we're doing here is we're just multiplying 18 times 4. So we have E equals 4 times 18, and we get E equals 72 eggs. Okay, so that's how we do this. Kind of a tough problem to start off on. Hopefully I explained that well enough, but this is a tough one in general. All right, next question. Tax returns. I don't even know how to say Stare charges $35 to file tax returns, but files for free if she only needs the easiest form. Then she donates $2 to clean water projects per tax return she files. Stare charged $7,245 and made a donation of $1,242 this year for the tax returns she filed. How many tax returns did she file at each price? Okay, this is where it tells us our variables. The question will always lead us to the variables that we need. So the first one we need is tax returns for free, and then tax returns for $35 each. We'll let F equal the number of free tax returns, and then we'll say, oh no, let's make it X for tax. Okay, this will be the $35, the number of $35 tax returns, tax. That's the number, okay? Just make sure to remember that. Okay, now let's break this down. $35 tax return. This isn't an equation, this is just a piece to add to one of our equations, okay? The other part of information we need is she donates $2 to clean water projects per tax return she files. Right. So this coupled with the donation of $1,242 for the tax return she filed. So those donations, we're going to make a donation equation. This is going to be our first equation, donation. And then we're going to have a money equation. So how much money she makes. Sterre had charged $7,245. So we'll need this piece of information also. And then free is also another piece of information. So we have our donation equation, we have our money equation. For donation, we know that for each money tax return, okay, that's X, she makes, donation. Sorry, no matter what that tax return she makes, so whether it's F or X, this represents the total, by the way. F plus X represents the total tax returns. Total tax returns, okay? You add your free ones and your money ones, and that's the total. She charges $2 per tax return she files. So if that's the total, we need to multiply this by 2 to get the total amount of money that she donates. Well, the total amount of money she donates is $1,242. So we multiply 2 times F plus X, and that equals $1,242. For our money equation, the one equation is down. For our money equation, we know that she charges $35 per, that means times, per tax return of the complicated variety. For free ones, she charges $0. And we know that the total cost was, we'll say, equals $7,245. Okay, that's the second one. Now, if you multiply 0 times F, you just get 0. So really this one can be 35x equals 7245. This is pretty cool because we can already solve for x. We can solve for x right away. What do? Well, we divide by 35. Okay, let me get my little handy-dandy calculator. Okay, so we divide by 35. So 7245. Oh, man. Don't you hate it when you hit the wrong button? 7245 divided by 35 equals. So we get 207. This means that she filed 207 money tax returns, the ones that cost $35. Okay, so one step down, one to go. Well, how do we find our F? Well, we have to plug this into the other equation. So the other equation is here. So we're going to have to plug this in for X over here. Let's go ahead and show that. I'm going to show it in blue. So we have 2 times F plus 207 equals, that's a 2. Sorry, that's ugly. Equals 1242. Running out of space. So we have 2F after we distribute plus, what is that, 414 equals 1242. So we do 1242 minus 414, and we get 828 because we mined this from both sides. We're doing a two-step equation here, people. 2F equals 828. Then we divide by 2, and we get F equals 414. So now we have our free tax returns is 414. Our $35 ones is 207, and we're done. Next question. I think we're going to have time for just one more, so bear with me here. We have a roller coaster train with 6 passenger cars, and the front decoration has a mass of 3,500. When the train has the front decoration and only 4 passenger cars, it has a mass of 2,400. What is the mass of the decoration of each passenger car? So it's telling us what the two variables are, the decoration and each car. So we'll let car equals the weight of car, or C equal weight of car, and then we'll say D equals weight of decoration. This is actually the easiest kind of system of equation to solve. It's like funny, we started off with the hardest one, we get easier and easier. Because the reason why this one's easy is because this first equation right here gives us the first scenario very clearly, no kind of dancing around, and this one is very clear also. So our first equation is going to be 6C, okay, 6 passenger cars with the decoration, there's only one decoration, equals 3,500. There's our first equation. Second equation, there's only 4 cars plus the same decoration, and that equals, what is that? 2,400. I'm going to use elimination here. So we have our two equations, very simple, okay? And now I'm going to do, what I'm going to do is I'm going to multiply this by -1, okay? And then I'm going to put it underneath here for elimination. So I get -4c minus 1d equals -2,400. The reason why I like to multiply by -1 is I think it's easier to always add with elimination. So we get 2c, this eliminates, equals, what is that, 1,100? So we get 5,500, I think, for the weight of each car. So C equals divide by 2, 5,500. Now all we have to do is plug this back into the equation. I'm going to go ahead and just plug it in over here. So we get 4 times 5,500 plus our D equals 2,400. So what we do here is we multiply 5,500 times 4. Patience. 5,500, not 5,500, 550 times 4. I think it's what, 2,200? Yeah, I don't know why I use a calculator. Shame on me. 2,200 plus D equals 2,400. So I subtract this from both sides, and I get D equals 200. Okay, so 200 for the weight of the decoration. Yeah, I want to say 5,500. 550 for the weight of each car, and there we go. Okay, the last one was, I just want to set it up for you, but I'm going to get going just because this video is already too long. For this one, there's 2 wings per bird and then 4 wings for some bird. So we're going to say W equals the weird bird, so the 4-wing bird, because it's weird, and then N is the normal bird, and this is a 2-wing bird. So you know that there's there N plus W equals the total of 2,800. This is very similar to the car one. Now, this is the interesting part. If there's a total of wings, well, how do we calculate how many wings? Well, the normal bird has 2 wings, so normal times 2, plus the 4 times W, 4-winged birds, which is super weird. And you know that the total wings is 4,038. As you solve this, I would recommend, by the way, to multiply this by -2 and then use system of equations. Once you do system of equations, you're going to solve for W first, and you get W equals 11. Okay? And then once you do that, you plug it back in, and strangely enough, there's lots of normal winged birds. How many normal winged birds are there? I think once you plug this back in to equations, so you plug this into here, and then you solve, you get N. What do you know? I'm doing the last one. I said I wasn't going to. N equals 2,008. Minus 11, I think it's 1997. Okay, so 1997 for 2-winged birds, and then 11 for these weird 4-winged birds. And there we go. Okay, hopefully you guys had a good time doing this, and you got the same success that I just had. Thank you for watching this video, and I'll see you next time.